Now we are going to talk about compute metrics. By using compute metric, we can know a lot of things about contours. So what is a contour? Any line, any curve or any shape which you are going to create by using add rect, add oval, arc 2, cubic 2, conic 2, etc. So by using these methods, whatever we are going to create is known as a contour. So this method is going to create a separate contour and this method is going to create a separate contour. And by combining these two methods, we are going to draw shapes like this. And those shapes are contained within a path. So those shapes are actually a subpath. By using compute metrics, you can know about length of a particular contour, or you can know about tangent, you can know about the angle between the tangent and a contour, you can know about in which direction that tangent is going to grow, these things. So let me just show you. So I'm going to use print here, and I'm going to use compute matrix method, and this method takes one more property, and that's false closed. We are not going to use it now. So this method is going to return a iteratable. We are going to store this iteratable in a list. So to convert it into a list, we are going to use toList method. So list is going to be of path metric. So now we are going to print the length of this list. So you will see it gave us a length of 2. Also, we can print length of this contour. First, I'm going to print the length of this contour. Then I'm going to print the length of this contour. So it gave us a length of 350. So how this length is calculated? So we are actually using formula to calculate parameter of a rectangle. Okay. So the height is here 400. Let me show you why height is 400. So we have given height here 400 and width 300. So we are going to pass so length here is 75 and breadth here is 100. So 2 into 75 plus 100 is going to give us 350. That's why we are getting 350 here. Similarly, for the last contour, because we are only having two contours here for the, so we are going to use last. It's going to give us circumference. So it's going to give us circumference of this circle. So as we know, the formula for to find the circumference is 2 pi r. 2 pi r. Okay. That's why we are getting value 470.477 approx. Also, we can create a subpath. We can also create a subpath by defining a, so by defining length. So we are going to extract a subpath and we are going to give a starting unit of 10 and the ending unit of 100. So let me extract this path. We are not going to print this, we are going to extract it. So path sub, and we are going to paint this path on the canvas. So you will see it created a subpath for. So this is how you can create a subpath from a contour. Also, there's one more property which is get tangent. So we are going to create a tangent on 50 unit, and let me extract this tangent in the tangent variable. So it's going to return a nullable tangent. So now we can extract the position of the tangent. So it's going to give us a value of 208.9 and 246.4. So where is this offset is going to lie? I'm going to show you. So for this, I'm going to create a line to this offset. So this offset is lying here. Now we are going to see in which direction this offset is going to grow. So this offset is going to grow in the direction minus x-axis 0.6 and a positive y-axis 0.8. So to show you, I'm going to add a polygon, and this polygon is not going to be a closed polygon, so I'm passing false here. Also, I'm going to run a loop which is going to start from 0 and it will go up to 15, and I'm going to specify offsets here. So in the x-axis we are going to pass 208.9 plus minus 0.6 multiply by index into 10. So we are going to grow by 10 units. Similarly, with the y-axis plus 0.8 into I into 10. So you will see it's growing in this particular direction. Now we are going to take a look at the last property, which is angle. So angle, it's going to tell us the angle between this particular curve and the tangent. So it's going to return angle in radians. So it gave us a angle of minus 2.23, which is somewhat around 127 degree. This is how you can use a compute metrics to extract metrics for contour. You can also create a subpath from that contour. You can know the growing angle. So there's one more thing. If that angle is in negative, so it's going to grow downwards, which is positive y-axis. So as we know, this is our starting point, which is 0 comma 0, and this way is the y-axis and this way is the positive x-axis. So it's growing in the positive y direction. If that angle is in positive, it's going to grow in negative y direction. It's going to grow in this particular direction. So this is all about compute metrics. If you want to learn more about Path, Custom Paint and Flutter Advanced, you can subscribe to the channel. See you in the next video.